Modern cabins often fight winter with a larger heater. Wartime builders began with a completely different question. Where is the heat escaping? They sealed the entrance. They added a second window. They insulated beneath the floor. They reduced the space that needed warming. Then they made stone remember the fire. These shelters were built quickly, cheaply, and under extreme shortages. Yet some stayed remarkably warm with very little fuel. Their real heater was not one stove. It was the entire building, and these 10 wartime decisions reveal why. During World War II, cold weather shelters had to satisfy an almost impossible set of demands. They had to be inexpensive, they had to be assembled quickly, and they often had to function where fuel, electricity, and construction materials were limited. Designers could not simply install an enormous furnace. Instead, they attacked winter in the correct order: stop uncontrolled airflow, reduce heat loss, warm only the occupied space, recover useful heat, then store whatever remained. The first secret began at the most frequently opened hole in the building. Opening a single exterior door can replace warm indoor air with a sudden wave of freezing air. Cold zone barracks reduced that exchange with a storm vestibule. A person entered through the first door, closed it, and only then opened the second. It was a simple airlock. The buffer space prevented the occupied room from opening directly into winter. One tiny entrance protected the temperature of an entire building. It produced no heat, but it stopped the stove from repeatedly heating air that would immediately escape. Windows were another major weakness. Their thin surfaces became extremely cold, while loose joints allowed wind to enter. Wartime cold weather buildings often used storm sashes. A second window layer trapped relatively still air between two surfaces. It was not modern insulated glass, but it followed the same principle. Instead of demanding more fire from the stove, builders improved the weakest part of the shelter. The cheapest heat is still the heat that never escapes. Insulation slows heat passing through a surface, but it cannot stop cold air traveling through cracks around that insulation. Wartime construction used building paper, interior linings, and carefully sealed joints to reduce wind penetration. This order matters. A thick wall full of gaps can still lose enormous amounts of heat. Before adding a larger stove, builders closed the invisible holes. Modern materials have improved dramatically. The principle has not changed. Control the air first, then improve the insulation. Warm air rises, but that does not make the floor unimportant. A freezing floor pulls warmth from feet, bedding, furniture, and everything touching it. Winter warfare manuals described floors constructed in layers. Boards were placed above the ground. Straw, sawdust, or other available insulation filled the space. Another board surface completed the floor. Walls and ceilings could be treated in similar ways. The occupants were surrounded by a complete thermal shell. They were not trying to create tropical temperatures. They were preventing cold surfaces from constantly drawing heat from the human body. Wartime engineers did not always attempt to heat an entire building. In Alaska, portable insulated shelters were placed around the part of an aircraft that mechanics needed to repair. The warm enclosure moved to the work. Cabins could follow the same logic. Curtains separated sleeping spaces. Unused rooms were closed. Entrances were isolated. A smaller zone warmed faster and exposed less surface to the cold. Modern open rooms may look impressive, but when fuel is limited, every unused cubic meter becomes another space the heater must defend. A stove releases heat through its metal body, but the exhaust remains hot as it travels toward the roof. An exposed section of properly installed stovepipe can release additional warmth into the room before those gases leave the building. The chimney therefore served two purposes. It removed dangerous combustion gases and provided another warm surface. This principle must never be confused with unsafe improvisation. Modern stoves require certified components, correct clearances, ventilation, and professional installation. The useful lesson is simple: safely recover heat before throwing it outside. Wartime heating systems were not automatically superior. Soldiers nearest a stove could become unbearably hot, while those beside exterior walls remained cold. Poor draft could fill shelters with smoke. Incorrect installations created fires. Carbon monoxide could kill without warning. Central heating later solved genuine problems by distributing warmth more evenly and moving combustion away from crowded sleeping areas. The goal is not to recreate every wartime method. It is to understand the intelligent physics behind the safer ideas. And the next idea may be the most memorable of them all. A metal stove becomes hot quickly. It also loses heat quickly after the flames weaken. Some wartime manuals showed field stoves surrounded by stone or brick. The heavy material absorbed energy while the fire burned. Then it released part of that energy gradually after the flames had faded. The stove provided immediate warmth. The surrounding mass stretched that warmth through time. Modern masonry heaters use a far more controlled and engineered version of the same principle. The fire stops first. The room cools later. That is how stone remembers. Radiant heat warms the surfaces directly in front of a stove. Wartime designers also found ways to move warm air through shelters. Some stove enclosures created an airspace around the hot metal. Cooler room air entered near the bottom. It warmed beside the stove and rose through the top. The enclosure transformed random heat into a more deliberate upward current. Later, convector jackets and heat shields used related ideas. The important detail was not a larger flame. It was deciding where the warmed air should travel. A heater is only as dependable as its fuel. Damp wood is harder to ignite, produces less useful heat, and creates more smoke. Wartime stove designs sometimes used low-grade waste heat to help protect or dry the next supply of fuel. The idea was to solve tomorrow's heating problem with heat available today. Modern firewood must never be piled against a stove or placed inside required clearances. But the broader principle remains valuable. Keep fuel protected, keep it dry, and never waste safe, low-temperature heat that could serve another purpose. The final secret reduced the problem to its smallest possible scale. Some wartime manuals described warmed stones, hot water bottles, or heated sand containers used in small shelters and casualty transport. Instead of warming every surface in a large space, stored heat traveled directly beside the person who needed it. Modern descendants are familiar. Hot water bottles, heated seats, radiant floors, warm masonry benches. Comfort does not always require heating an entire building. Sometimes it requires placing warmth at the body's most important contact points. Modern builders did not completely forget these principles. Central heating was safer, more convenient, and more even. It allowed larger rooms to remain open and reduced the daily work required from occupants. But as mechanical heating became the expected first solution, passive techniques became less visible. A thermostat could compensate for drafts. A larger furnace could compensate for excessive space. The building itself was no longer expected to perform as much of the work. We did not lose the science. We often lost the sequence. Wartime builders could not fight winter with unlimited fuel, so they recruited the entrance, the windows, the floor, the ceiling, the chimney, the stones, even the size of the occupied room. Modern cabins contain better equipment, but even the best heater will struggle inside a building that constantly throws warmth outside. The deepest wartime heating secret is therefore also the simplest. Do not begin by creating more heat. Begin by giving heat fewer places to escape. Which of these 10 ideas surprised you most? Tell us in the comments. Thank you for watching. Subscribe for more forgotten engineering, historical building secrets, and technologies that modern construction may need to rediscover.